Hello and welcome everyone. Thank you all for joining us today for this live stream event. Before we begin, I'd like to review two items. Our code of conduct. So Microsoft Reactor seeks to provide a respectful environment for both our audience and our presenters. We encourage engagement in the chat, but we just ask that you're mindful of your commentary remaining professional and on topic. Our event guidelines. So this session is streaming to you live from Microsoft Reactor's YouTube channel. So it will be available for on-demand access at the conclusion of the session in case you want to revisit anything that's covered today. If you have any questions, feel free to drop those questions or comments into the chat. This is a YouTube live session, so if you are not familiar, you do need to have an account to interact in the chat, so feel free to create that account now if you haven't done so, or sign in so you have access. Which brings us to today's session. So today we're joined once again by Josh, a cloud advocate here at Microsoft for data. And Josh will be covering for the month of JulyOT, creating intelligent autonomous systems with Project Bonsai. So let me bring our speaker up, just one second. Hello, Josh, welcome. Thank you for doing another session with us today. Oh, you're muted still.
Sorry about that.
Happens to the best of them.
Yeah, thank you for having me today.
Awesome. Thank you so much. I'll let you take over from here and introduce yourself more thoroughly if you'd like.
All right. Thank you. So, my name is Josh. I'm a cloud developer advocate here at Microsoft. And today we'll be covering a session on creating autonomous systems with Project Bonsai. So for today's session, it's the first session in a three-part series. So we have three sessions as part of this series on introduction to Project Bonsai, and today we'll just do a high-level introduction to what Project Bonsai is, and also cover and how you can leverage Project Bonsai to build autonomous systems for your organizations. Also, just to mention, this session is part of JulyOT, so I'm sure you've been able to join. Maybe you've been able to join other JulyOT sessions. So this is also part of the ongoing JulyOT sessions. Right. So to move on, the agenda for today's session is we'll cover on what autonomous systems are, and also as part of that, we'll also look at autonomous AI. Then we'll look at what is Project Bonsai, Microsoft Project Bonsai, how it works, and then when to use it. Then we'll just do a quick knowledge check and a summary of the session. So we'll not do a demo as of today's session, but we'll be able to cover in depth what Project Bonsai is and also autonomous systems. And then for the future video series, for the future sessions, the second and third one, we'll be able to build a Bonsai brain and also deploy it to a device as well. So, but for today, we just cover on what autonomous systems are, autonomous AI, Project Bonsai, and also how it all works. So to begin with, let us look at the evolution of control systems. And to look at this, we'll look at how control systems have evolved over time. So today's autonomous systems are ushering the next evolution of industrial systems, but we need to look back at how everything began. And in the first industrial revolution, we harnessed steam and electricity to power mechanized systems. So we had mechanized systems that were powered by steam or electricity. And then almost a century later, we began automating these industrial systems using software. So we had industrial systems that operated we had industrial systems that operated on rigid and fixed set of instructions that were programmed by developers. So you had these automated systems where they just followed a strict set of instructions and they couldn't do anything beyond what was defined in the software because they just followed those set of instructions. But next, where we are today, we have autonomous systems that are powered by artificial intelligence. And so these are ushering the next evolution of industrial systems where now you have the physical world being infused with intelligence to create interconnected autonomous systems. So they do not just follow a fixed set of instructions in software, but now we have these autonomous systems that are capable of sensing the environment and also reacting, or rather providing feedback based on the environment they are in. And so they're going to react differently, or they're going to provide different results depending on the environment they are in. So they are able to sense and also adapt to the environment they are in. And so these autonomous systems here are powered by artificial intelligence. And as you can see from the mechanized systems, these were heavily manual. The operation of these systems was heavily manual, as you can expect of any steam or electricity powered system. And for the automated system, so this one, it's fixed operation. As I said, like you had software running on these systems, and they just follow the particular set of instructions on that software. But now for the autonomous systems, this one operation in this is more of an intelligent operation, where they are able to adapt differently depending on the environment they are in. Now that we have a brief understanding of what autonomous systems are and how we've gotten here, next let's have a look at autonomous AI. So when we talk of autonomous AI, we refer to automation that is powered by artificial intelligence. Therefore, autonomous AI will help to optimize equipment and processes by sensing and responding to the inputs in real time. So depending on the environment an autonomous system is in, the autonomous AI will help that particular system to respond to the inputs in real time. So it optimizes equipment and processes by sensing and responding to inputs in real time. And most machine learning technologies, they can sense and perceive complex relationship based on data, but they cannot make decisions. So, but in contrast, when you have autonomous AI, this is focused on making decisions in a flexible and an adaptable manner as the inputs change. So this ability allows the autonomous AI to make more human-like decisions and address a variety of common problems in manufacturing, logistics, and other areas. So now that we understand what autonomous systems and autonomous AI is, let's now have a look at Project Bonsai, which allows us to build intelligent autonomous systems. So Microsoft Project Bonsai is a low-code AI platform that allows you to accelerate the development of control systems that provide operator guidance or make independent decisions. So with Project Bonsai, you are able to build autonomous systems that can optimize process variables. They can also improve production efficiency, and they can help reduce downtime. Think of this, think of the AI that you build with Project Bonsai as augmenting the human operations where it is deployed. It can work independently, or alternatively, it can help guide the human beings working in the same environment to make informed decisions, as we're going to see in a scenario shortly. So let's have a look at a scenario that will help us, that will form the basis of our argument to understand what Project Bonsai is and how it actually works. So suppose you work for a soap manufacturing company, and the company uses the extrusion process to produce soap. On top of that, it uses an advanced process control system to manage production. So as an engineer, while you're managing the advanced process control, you strongly believe that the manufacturing process, you strongly believe that when you change the manufacturing process, you can improve the production yield. So to make the changes, as an engineer, you send new commands to the advanced process control system to control manufacturing, and the advanced process control system will then adjust the manufacturing equipment accordingly. So you realize this process is very complex, and it can be very difficult to control and optimize production, because you'll have to adjust parts of the manufacturing equipment. You'll have to have variations in terms of the raw materials. And you also need to consider the wear and tear of the machine. And also, because of you need to take into consideration the residue from the previous runs, and that is going to affect the production, or rather how you optimize your production. So in this kind of a scenario, if we look back at the systems we had talked in the previous slide, in the case of automated system, if they're following a rigid set of instruction, then they can work in an ideal scenario. But in this scenario that I've provided, you realize it ends up being a chaotic kind of an environment, because there's a lot that are changing. We have wear and tear of the machinery. We have variation in the raw materials. We need adjustments to be made on the manufacturing equipment. You have residue from the previous lines, so you realize the environment keeps changing depending on all of these variables. And so it becomes very hard to use an automated system for this. And so if you are an individual on this plant and you decide to tackle this problem manually, you realize it's going to take time for you to be able to make these changes, or rather to make these changes in the manufacturing process for you to optimize production, because there's just a lot of variables that you need to consider. However, if you are to leverage Project Bonsai, this is how you would approach this problem. One, you will leverage engineers or subject matter expertise who can be able to teach the best practices to your AI. And notice that I'm using the word teaching best practices to the AI, because this is the point where I introduce a concept called machine teaching, which we'll be seeing in the next few slides. So the first step will be having this subject matter expertise who've worked on this plant for a long time to teach the best practices to the AI, because you realize in this kind of in most manufacturing, in many manufacturing plants, or in many factory floors that involve manufacturing, the key asset in those environments is the skills of the operators, the people who are operating these plants, the skills they have acquired over years. That is the most important asset any manufacturing plant can have. And so having this subject matter expertise teach the AI, and come up with a curriculum, break down the steps so that the AI can learn is the very first step for you. And that's how we approach problem solving on Project Bonsai, is we leverage subject matter expertise to inject their knowledge into these AI into these AI into these intelligent agents. Next, once we have the subject matter expertise once we have them teach the AI, now the AI can then perfect those methods inside a simulated environment. So we set up a simulated environment where the AI is able to learn, or rather to practice whatever it has been taught. So it combines and adapts and also revises techniques to test millions of transition scenarios. So it's able to practice, and it can do this in very, very many runs. And if it fails in simulation, it's able to correct and also make an informed decision the next time it's making the next time it's undertaking those decisions. And we'll see these the moment we start talking about reinforcement learning in some few slides from here. Next, once we have the AI practicing in simulation, we can now be able to deploy this intelligent agent onto the factory floor. And then you can be able to have this AI to help the new hires and less experienced professionals to perform advanced tasks on the plant floor. So what that happens is people can now be able to leverage this AI to make informed decisions on the floor. So someone who is less experienced or someone who is a new hire can be able to work hand in hand with the AI and be able to make informed decisions on the plant floor. And one of the most important things is, because we are testing all of this, because we are teaching and the AI is also learning in a simulated environment, the time it will take for an individual to calibrate the plant can be reduced from months to days, because it's able to test all these different scenarios in simulation before applying them in the real world. Because for any other individual who will have to do this manually, they'll have to do this with the plant machinery and these will take a long time to calibrate. But when you do this in simulation and you have all these different scenarios that you are able to test, you can be able to reduce the calibration time from months to days. The last thing to note when you leverage Project Bonsai to create these intelligent agents, because you're doing this from a simulated environment, this creates an ideal testing environment for new methodologies and formulas without risking the operator safety. So you are able to do all of this with safety in mind, because all of this is happening and the AI is learning all of this in simulation. Therefore, even if it fails, it's still safe. So you are able to do all of this without risking operator safety. Now that you understand how you can be able to take a simple, like from the soap manufacturing scenario, and you understand how Project Bonsai can be able to plug in to help you make these informed decisions. Next, we're going to understand how Project Bonsai understand how Project Bonsai works by describing the underlying logical elements. So from this image, you can be able to see the different elements that make up the Bonsai service. So all these elements include the training simulator, the training engine, the training curriculum, and also the integrated simulator, and the trained AI, or what we now call the Bonsai brain. So we're going to look at these elements one by one so that we can be able to understand how they all come together to create the Bonsai platform. To begin with, we have training simulations. So training simulations replicate the real world to create a realistic context for Bonsai brains. As I mentioned previously, you use simulations for the Bonsai brain to practice in. So when you teach your AI, it's able to practice in simulation. So you can be able to add simulations from a range of Bonsai simulation partners. So for example, you can use MATLAB from MathWorks. You can also use AnyLogic or you can also integrate your own custom simulators using the simulator API. So training simulations, when you're training your brain in simulation, the simulations, they'll model real world processes and change state as the Bonsai brain applies actions. So the training tasks, they can be as simple as stand up, or they can even be as more challenging as learn to dance, learn to walk, or even optimize a chemical process in a chemical plant. So, and this can be applied in very many areas, as we'll see as we'll see in an upcoming slide, some of the industries where you can be able to leverage Project Bonsai. But one of the most important things that I need to mention here is that for any simulation that you're going to use with Project Bonsai, it needs to have a defined start state, and needs to iterate over time, and also needs to respond to external actions. Because when you apply, the brain needs this state, a defined state, and then it applies the decision it makes. The simulator needs to apply that and then iterate over the same. So for any simulator, regardless of what simulator you use, whether you use your own custom simulator using the simulator API, or you build your simulator using MATLAB or any logic, any simulator needs to satisfy those conditions for you to use it on Project Bonsai. That it needs to have a defined start state, it needs to iterate over time, it needs to respond to external actions. Now that I've mentioned about the simulator and how, and that's where the brain learns, let us look at something called reinforcement learning that allows the brain or the intelligent agent to make optimal decisions. So I know you've heard of these other kinds of, maybe you've heard of these other kinds of machine learning techniques, such as supervised learning or unsupervised learning. And and also reinforcement learning. But just to give you a quick overview of what supervised learning and unsupervised learning are, in a supervised learning scenario, you give you start with a labeled data set. So with a labeled data set, that means you have, for each data set for each data set you have, you also have an answer or a solution given to it. So this helps the model to learn and provide the result of the problem easily. So that is in the case of a supervised learning. So this will be maybe like a regression problem. But in the case of unsupervised learning, you do not have a labeled data set. So this is more of a self-organized learning where the AI needs to find previously unknown patterns in the data set without pre-existing labels. So in this case, it's able to answer questions like, is this weird, or figure out patterns, how a particular data set is organized. But so the major difference between supervised and unsupervised learning is that there is no complete and clean label data set in unsupervised learning. But now in reinforcement learning, it's completely different between the two. We don't have like we don't necessarily have a clean label data set as per se, but in reinforcement learning here, the algorithm needs to learn how to react to an environment on its own. In short, it needs to answer the question, what should I do next, depending on the environment it is placed in. So to be more specific, reinforcement learning is a type of learning that is based on the interaction with the environment, purely based on the interaction with the environment. And that's why reinforcement learning becomes a very important tool for us when we are building our intelligent agents on Project Bonsai. Now that we understand what reinforcement learning is, let us talk more specifically about deep reinforcement learning. So you may have heard about the work that DeepMind has done with solving the game of Go. So what they've actually shown is that reinforcement learning can learn strategy. It can learn creative ways to solve problems, similarly to human beings. But in most simple terms, just to explain what deep reinforcement learning is, it means that the system is learning by practicing. So there is a lot of practice, or there are a lot of iterations that the system undertakes for it to ensure that it learns. So it tries different configurations or options and learns what the result are based on the actions it took from the various configurations, and then it tries again. So if you can see in the illustration that I've shown, you have a robot there that actually takes an action, whether in simulation or in a physical system, and then it based on the action it has taken, the system assesses that, and then it rewards the intelligent agent based on whether it did right, or it took the right action, or it didn't take the right action. And then after every action that this agent takes, you end up with a new state, and then using this state, you can be able to use that again in the simulation or in the physical system, and then this process loops over, and that's how we leverage deep reinforcement learning to learn. So deep reinforcement learning is well suited for complex and dynamic environments, unlike other machine learning techniques that I had already mentioned. Now that I've mentioned about deep reinforcement learning, it doesn't work single-handedly on Project Bonsai to train our intelligent agents. We need to introduce another concept called machine teaching. So machine teaching is a technique for infusing subject matter expertise into deep reinforcement learning model. Going back to the scenario that I had given for a chemical plant, I mentioned we need to take the subject matter expertise and get the skills from them to teach our deep reinforcement learning models. So machine teaching is actually telling the system the key concepts that you want it to learn. What are the levers and the knobs that are important to your system and processes which will affect change? So our machine teaching approach will allow you to do three things that are tremendously helpful. One, it's going to allow you to incorporate subject matter expertise into your deep reinforcement learning models. You're also going to achieve faster training times, and also allows for explainability, helping the AI to show you which skill it's utilizing during each given step in the process. So in this case, the end product for machine teaching is actually not just a black box, but there is a lot of explainability that in where you can be able to understand how the AI is actually operating and what skill it's actually utilizing at each given step. Now, to help you understand what machine teaching is, think of a scenario where you have two kids that want to learn how to play football. Now, you place one child on a football pitch with the other, and then you just tell them, just go and play, just go figure out how to play on your own. And then take another kid and place them on the same pitch, and then give them a coach. And then with the coach breaks down the problem on how to play football by coming up with objectives. For example, the objective to score a goal or score more goals than the opposition. Also shows helps the kid understand the rules of the game and also the strategy of the game. The result of both scenarios is both of them will learn how to play football eventually, but the second child will learn more faster because they had a teacher, they had a coach who was guiding them on how to play football. So it's in the same case as machine teaching. What happens is you have a subject matter expertise who has been on, like in the same case of the soap manufacturing, you have a subject matter expertise who is experienced in the manufacturing process. And so that person uses their skills to teach this intelligent agent how the manufacturing process works. So what happens is, because this AI is being taught by an expert, and the expert already has crafted a curriculum with specific goals, with specific objectives that the AI needs to accomplish or that the AI needs to meet, then it's going to learn faster. So the training times are going to be considerably high. And also, because you are incorporating your subject matter expertise, it allows also for explainability, where you have the AI can show you what skills it's utilizing during any given step in the process. So how does this all fit together? We'll look at these in a later stage of this presentation. Now that we understand the training simulator and everything that goes ahead, everything that goes into simulation, and we understand the concept of machine teaching and reinforcement learning, let us look at the next element of the Bonsai platform, and that is the training curriculum. So goal in the training curriculum, the person who is teaching the AI, or the person who is teaching the intelligent agent, comes up with the goals and objectives, and these are comprised inside the training curriculum. So the training curriculum will allow you to use your subject matter expertise to break down complex problems into key objectives that the AI can learn. So think of goals as high-level specification of what you want the system to learn. For example, if I was balancing a ball on a plate, a simple, and I wanted the ball to remain at the center of the plate, if I needed to train an intelligent agent to do that, then what I will do is I will break down that problem into goals. And some of the goals will be like avoid the ball from falling off the plate, and the other one will be ensure the ball moves to the center of the plate. So once I break down that problem, it seems to be a complex problem initially to balance the ball on the plate, but once I break it down into goals, then I can be able to encapsulate my intentions for the AI, and then it can be able to work towards meeting those goals. So the curriculum, it just comprises of the goals and objectives that you want the AI to meet. And so to define our goals and objectives, Bonsai uses a single purpose language that is called Inkling to encode the goals and objectives. And in the next session, we're going to actually go through the Inkling code for one of the Bonsai brains that we'll be creating. The other element is the training engine. So the training engine manages the AI for Bonsai brains based on the training curriculum you've defined in the Inkling code. And so the training engine itself has four components. The first component is the architect. So the architect generates the models based on the training curriculum. So based on the training curriculum that you've defined, the architect will be able to generate the learning modules. Another component of the training engine is the instructor. So this one coordinates the training for the learner based on curriculum and training data that the simulation provides. We have the learner that gains the experience at solving the problem based on the direction an instructor provides. And the last component is the predictor that reports on how the learner behaves when presented with the new data. And the predictor represents the trained brain that will be exported. So all of these components become very essential when you're training your bonsai brain. So the training engine has all of these components that actually work hand in hand. So you'll have the architect that will generate the learning models, the instructor that will coordinate the training, the learner which gains experience at solving, and the predictor that actually kind of represents the trained brain that will eventually be exported when the training process is completed. The other element of the Bonsai platform is the Bonsai brain. So the Bonsai brain is an AI model that's learning on the AI platform. So the training engine will guide the brain as they learn on the provided curriculum. So, and the good thing with Project Bonsai is you can be able to train different versions of your brain. So like you can be able to create a brain, and then once the training is complete and maybe you've exported it, you can be able to create a new version. If you make changes to your curriculum, you can be able to create new versions of your brain. Just to have a deeper understanding of the bonsai brain, it's the AI model that we've built by combining the two techniques: deep reinforcement learning, machine teaching, and simulation. So unlike other AI models, bonsai brains are able to make decisions in real time. So they make decisions about what they do in real time, and they are a lot more like control systems. So we train the brain by letting it practice in simulations, and then we leverage teaching techniques to capture and codify what humans already know about controlling and optimizing systems as we design and build these brains. Now, how do we use Project Bonsai to deliver AI powered automation? So this is a quick summary of what we've been able to cover from all the elements of Project Bonsai. So the first thing is the machine teaching, the subject matter expertise will, the subject matter expert will infuse or will inject this subject matter expertise into the brain during training using machine teaching. So through machine teaching, we are able to inject subject matter expertise into the brain. Then, once we inject the subject matter expertise into the brain, we use simulation tools for accelerated integration and scale of training. So the only way we train brains on Project Bonsai is allowing it to practice in simulation. And then using goals, objectives, and assessments, we are able to train adaptive brains. So we specify a curriculum, and then using that and real-time assessments, we train the bonsai brains. And finally, once you've finished training and you've seen significant results after training your bonsai brain, we export the optimized brain and deploy it either on the cloud, on the edge, or on premise. And we'll be able to see that on the last session on this series on how to export the optimized brain and deploy it on the edge using Azure IoT Edge. Now, how does Project Bonsai actually work? Now, we've understood all these different elements. We've been able to understand all these different elements: the simulator, the engine, the training curriculum, and also the Bonsai brain. But how does all of these actually work? So in a typical scenario, you'll start by identifying the problem you want to solve by using AI, and then you'll take the following important steps. So you'll create a simulation that models the real world environment in which the AI will operate. So you can be able to create your simulation using either the simulator API. So you create a custom simulation using the simulator API, or you can use one of our simulator partners, such as MATLAB, using MATLAB from MathWorks, or Simulink, or or any logic. Once you've created a simulation, next you test and verify that the simulation actually works locally. So from the Bonsai platform, you can be able to connect to a simulator even if it's actually running locally. Then you use a connector to import the simulation as a managed simulation package in Bonsai. And then you design a teaching plan in Inkling using goals and objectives. So you come up with a curriculum that encodes your goals and objectives that you want your brain to learn. Then you're going to train and assess the brain's performance. So as the Bonsai brain is training, you'll be able to see these custom assessments, and then you can be able to leverage those to assess the performance of the brain. Once you finished training, you then export the trained AI as a Docker container. And so these, you should only export your fully trained AI after you determine that the brain is trained appropriately. And then you can be able to run verification against the AI, and then deploy it, deploy and integrate it with your real world control system. Now, now that we understand, now that we understand how Project Bonsai works, we understand how Project Bonsai works and how you can be able to leverage it to build your intelligent autonomous systems. Let us look at the industry challenges that are well suited for AI. So, in what particular industries are well suited to use these technologies? So, when you have so the first thing is you look for extreme robustness requirements. So for example, motion control system makers, they must tune their PID controllers for a machine model, machine type, and factory condition. So the tuning process will take time, and also there's a huge backlog. So you look they are best suited for scenarios where you have multiple competing or changing optimization goals. So that's the first one. Then the other one is where you have an operator overload. Remember when we mentioned that you can be able to leverage this AI in environments where it can either work entirely on its own, or you can be able to use it alongside alongside human beings. So in areas where you have an operator overload, like a manufacturing process where you're trying to process 900 different alerts and errors, and an operator must process them in real time to decide the optimal speed of the machine during operation. Then in that kind of a case, an AI model is best suited because it can be able to process all these different alerts in near real time and be able to provide the right course of action. And also the other one is when where performance targets require fine tuning. So at this point, I'm going to show you the Bonsai platform just to provide a quick understanding of how the platform looks like. So to start with, when you open the Bonsai UI, or rather the Bonsai web portal, you can start by creating a new brain from the left side. So if I click on create a new brain, I can be able to select some of the sample projects that we already have. So in this case, I can create, for example, can be able to create the Moab brain. So I'm just going to give it a name. So once you click create, it should create your new brain. Let's see whether it created. Yep, it should create your brain right here. So if you open that, you should be able now to see this interface for the Bonsai web UI. So the web UI has three major parts. The first one, we have this left panel. We have this left panel right here. We have this, sorry about that. It's taking long to load. So as I'm waiting for that, so I'm going to refresh the page just in case it's taking longer to load. Let's see. Okay. AI. All right. All right. I'm just going to try and log out, and then we can start. We can start again. Let me sign out. Right. Then we can try signing in a new tab. All right, so just sign in. So for you to do this, you need to have an Azure account. So just going to sign in. All right, sorry about this. Okay, so let's sign in. Okay. Okay. So after signing in, all right. So after signing in, we just need to select the subscription where you've created your Bonsai workspace. So it's going to select, you can select the Azure Active Directory tenant and then you select the subscription. So I'm just going to select my subscription tab. And then the next thing I need to select my Bonsai workspace there, and then just click on get started. So after that, it opens up these default web UI portal. So on the left pane here, you can be able to see a list of all your brains, all the simulators, and also exported brains. You can be able to access them from here. So I'm just going to click on create a new brain, and then again, because I'd given an example with the chemical plants, I can try creating one. Seems like it's not here yet. Okay, so for a start, I can just create a Moab brain. So just give it a name, Moab, and then create brain. So that will go ahead and create a new Bonsai brain. And if you expand right here, it should appear on this list here. So on the left here, as I mentioned, you can be able to see all the Bonsai brains. In the middle here, we expect to see the coding panel. On the top, on the far right side, we expect to see the graphing panel that shows a graphical representation of your bonsai brain. So this is taking a little bit longer to load. We'll come back to that at the end. At the end, we can just continue on with the slides. All right. Now that we've done a quick introduction of the bonsai brain, of project bonsai. Next, let's have a look. Let's do a quick knowledge check. Before we go back and try doing a quick demo on the bonsai platform. So, which component in bonsai is responsible for generating learning models based on a training curriculum? Is it the simulation engine, the training curriculum, or the training engine? So the correct answer for this one is the training engine. So remember, from the training engine, we have several components. So we have several components in the training engine, and one of the components in the training engine is the architect, and the architect component of the training engine is the one that generates learning models. And the next question, in which of the following scenarios could bonsai be of some benefit to an organization? A, an organization that has concluded that there is considerable scope for improving automated production system, an organization that uses little in the way of automation systems, an organization that has no simulations and no experts skilled in working with simulations. So in this case, an organization that has concluded there is considerable scope for improving automated production systems. So this scenario is the one that is ideal for Project Bonsai because there is already scope for improving automated production system. But an organization that uses little or no automation systems might not really benefit from Project Bonsai. Then the last question for knowledge check is, which statement about bonsai brains is accurate? So the bonsai brain can only contain one version. Bonsai brains learn a given curriculum through iterative training with a training engine. When you're happy with your bonsai brain, you can export only the latest version. So the correct answer for this one is B, that bonsai brains learn a given curriculum through iterative training with a training engine. So A is not accurate because you can be able to export multiple versions of your bonsai brain. So when you train your brain, you can be able to have multiple versions of your brain, and you can be able to export either of the versions. So not only the latest, but you can be able to export either of the trained brains. I'm just going to let's try our luck again. Let's try our luck again in with the Bonsai UI portal, and yeah, it opens this time. It opens. All right. So as I was mentioning, we have three parts of the Bonsai Web UI portal. So we have this left panel that lists the different Bonsai brains you've created and also their versions. So like if you were to open like this one, each of the brains that I've created here, you can be able to see a version inside each of them. So you can be able to see each of them has a particular version. We also have the different simulators inside here. So if you were to expand here, you can be able to see the simulator for the chemical continuous stirred reactor tank. And we would see one for Moab. And you can be able to add even your own custom simulators. If you click on add here, you can be able to see the different simulators that are supported, and even your own custom simulator, you can be able to add it right from there. You can also be able to see the different brains that you've been able, the different exported brains. If you come down here, you can be able to see the different brains that we've been able to export. So seems like we're having a little bit of problems to load the coding panel and the graphing panel, but hopefully we'll be able to do this in depth next week when we'll be creating our first bonsai brain, and as well as train it before deploying in the next session. So thank you so much for joining in today's session. Apologies, we were not able to show the demo on the Bonsai Web UI portal, but we'll be able to do this in depth next time. So some bit of resources, you can just have a look at the project introduction to Project Bonsai Microsoft Learn module path, so that you can be able to learn more about Project Bonsai, and also have a look at Inkling, because we'll be leveraging more of that in the next session. So thank you, and hopefully I'll see you next week for the second part of this series.
Thank you so much, Josh. This was great. And thank you for our audience for tuning in. Until the next one, if you are tuning in for the first time and not familiar with the Microsoft Reactor program, we offer a lot of free, inclusive virtual sessions online, focused largely on various components in the tech industry. And then also we have physical spaces around the world. So if you happen to be near one of them, feel free to check out that calendar and potentially come on site for an in-person. You can visit us on meetup.com. We have a website that should be back online and active very soon. So stay tuned. And Josh, I'll see you next week.
Thank you. Bye-bye.
Take care. Bye, all.